Define power. Power is the work done per unit time. Of course, there are other variations of the definition of power: energy gained per unit time, energy used per unit time. Remember, to do work, energy must be used, but work can also result in energy being gained. So when work is done, energy is used. That's why it is fine to say work done per unit time, energy used per unit time, energy gained per unit time. Mechanical power, P, can be calculated using the formula P is equals to FV. Use the concept of work and the definition of power to show how this formula is derived. So we want to derive the formula P is equal to FV. Now, to derive that formula, we must understand that they told us to use the concept of work and the definition of power. So they actually gave us hints. So the definition of power is work done over time. The definition of work is force times displacement. So where there is work, we replace with force times displacement. But we know that the speed or velocity is equal to displacement over time. That's the average speed, or just the general speed is displacement over time or distance over time. So where there was S over T, we replace S over T with V. So power, and therefore becomes power is equal to FV. Right? So the next question says, the engine of the lorry provides 130 kilowatts of power to the lorry's wheels. So the engine is providing the power when it is traveling at a constant speed of 25 meters per second along a straight road. Show that the resistive force opposing the motion of the lorry is 5,200. Now, understand the first things first. The lorry is said to be traveling at a constant speed of 25 meters per second. So constant speed in physics should ring alarm bells. Constant speed means that the resultant force is zero, meaning that if the resultant force is zero, then the force is acting forward and the force is acting backwards are equal. So, for example, if we are to draw for the lorry, we can say that the lorry, this there is the lorry. Okay, so the lorry is a forward force due to the engine. We are told that the engine is providing a power. So let's just say that that's the drive force due to the engine. Then we have a backward force due to the resistive force. Let me write it FR like that. So we are so sure that we are not told of any other forces except for these ones. We are said to show that the resistive force opposing the forward motion of the lorry. So we are also told that the engine of the lorry provides 130 kilowatt of power. So definitely it is providing a force, the engine. So there are only two forces we are aware of here in this case. So it means that those forces are equal. The drive force of the car and of the lorry and the resistive forces are equal, so that the resultant force is zero and it is moving at constant speed. So if that is the case, then we proceed and we say that, okay, so power is equals to force times the speed at which the object is moving. In this case, we use the F. F will be the drive force of the engine, because the force is due to the engine. We are told that the engine of the lorry provides a 130 kilowatts of power. So if the engine is the one providing that one, and we know that it is moving at a constant speed of 25 meters per second, then it means that the force that we find is the drive force of the engine. So we can find the drive force of the engine. Why are we finding it? Because we have said that the drive force of the engine is equals to the resistive force of the on the car, on the lorry. So by finding the drive force of the engine, we make F subject to the formula of power over V, which is 130 times 10 to the power of 3, because it was kilowatts, divided by 25. That will give us 5,200 newtons. That there is the resistive force opposing the forward motion of the lorry, because it is also the drive force. and they are equal because constant speed, meaning that there is no acceleration and the resultant force is 0. The lorry in B travels up a straight section of the road that is inclined at an angle of theta to the horizontal. Now the road now in this case is now inclined. If you check, this road here was a straight horizontal road, as was said here. They said that it was a straight horizontal road, but in this case now what has changed? Now this road is now inclined at an angle theta to the horizontal, as shown in fig 3.1. So the diagram fig 3.1 here is showing us it being inclined at an angle of theta to the horizontal. So it's no longer traveling along a horizontal ground. The lorry has a mass m and the acceleration of free fall is g. Determine an expression in terms of mg and theta for the component of the weight of the lorry that acts parallel to the surface of the road. This one, we don't even need to justify it or try to make logic out of it. It's a very simple. You must always know the component of anything that is going up the plane, the component along the parallel to the plane, the component of the weight of any object parallel to the plane is equal to mg sine theta. So if the component is equal to mg sine theta, it is a matter of fact, you must know that one. So then the question says, the resistive force on the lorry remains unchanged at 5,200 newtons, and the engine now provides a greater power to maintain the speed of 25 meters per second. So the engine still needs to maintain a speed of 25 meters per second, but the total resistive force has not changed. The engine now provides a greater power. So the question is, why is it providing a greater power? It's providing a greater power because the forward force that is now required is now more. Why is the forward force now more? Because there are two now, whereby at first there was only one force going backwards, which was 5,200 when it was horizontal ground. Now there's also a component of the weight which is going parallel to the plane. So in other words, the drive force has to increase. It has to increase so that it can match the forces going backwards. If it matches the forces going backwards, then the resultant force will be 0, and it will continue to move at a constant speed of 25 meters per second as they want. So the drive force has to increase. But if the drive force increases, then the drive force F multiplied by the speed of 25, then it means that the power will have increased. That's why they say that the power, the engine is now providing a greater power here. Engine now provides a greater power. The reason is to maintain a speed of 25 meters per second. It must provide a greater power because the backward forces are now more. The total mass of the lorry is 36 kgs. The angle theta is 1.4. Determine the power in kilowatts now provided by the engine. So first and foremost, power, remember I said that if it is traveling at 25 meters per second, we just need to know the drive force. So to know the drive force, we must know that if it is going to move at a constant speed of 25 meters per second, the drive force is equal to all the forces going backwards. So it's equal to the 5,200 plus the mg sine theta. That's what we write here. Drive force equals to 5,200 plus mg sine theta. Like that. So once this is clear that the drive force is equal to these two, then we are told that the mass is 36,000, g is 9.81, the angle of incline is 1.4. Then we know the other force going down along the plane but down the plane to be 5,200. So when you add those ones, they give us 13,800 newtons. That's our drive force. So using the formula, power is equal to Fv. Since we now know the drive force to be 13,800, we multiply that by 25. That gives us the power, the new power right now. Now we divide that power by 10 to the power of 3 to give us the power in kilowatts as they wanted there.